చెప్పండి.
See, can you solve 8th week assignment problem, sir?
Which assignment problem?
8th week.
Okay. Let's do that then. Yeah, can you see the question?
Yes, sir.
Okay. So, the first question is, you have n random variables. You want to be n, and so these random variables take values -1 and +1. So now they give you this random variable x. So here probability of the I equal to ±1 is equal to. Right, now x is another random variable. X is equal to sum over of bi bj. They ask you what is the expectation of x. So expectation of x is equal to sum over of expectation of bi bj. So what is the expectation of this term? So expectation of bi bj is equal to, so if I is not equal to j, so then the expectation of bi bj is equal to 0, because bi bj uh, bi bj will take will will acquire the value 1 with probability half, and -1 also with probability half. So if I is not equal to j, then the expectation of bi bj is equal to 0. And if I is equal to, and if j is equal to I, then uh, then bi, then it's basically bi squared, and bi squared is equal to 1, so it's not even a random variable, it's equal to. So the expectation of, to summarize, expectation of bi bj, you can just write it as delta ij. So delta ij is called the canonical delta. It means 1 if I is equal to j, sorry, if I is equal to j, and 0 arguments. So the expectation of x is equal to sum over of delta ij, I comma j. That's equal to. Is it clear?
Yes, sir.
Yeah, if you don't understand something, you can just stop somewhere.
Okay, sir.
Then the next problem is a good problem. I'll ask you if you can think of a solution. Just give me a second.
Okay, sir.
So let's look at this problem. So there are n unit vectors in Rn. Now the question asks us, so you understand what a unit vector is, right? So unit vector basically means that if you take the dot product, it's equal to, with itself, it's equal to 1. Basically means that Vi dot Vi is equal to. So now the question is, there exists a binary vector. So do you understand this notation? If I say B is -1 to 1 to the power n, then you should think of B as this vector. So B is basically this vector, where each of these B's are drawn from -1 to 1. Okay. So now, which of these options are correct? There exists a vector like chosen from -1 to 1, such that, so if I write this vector, let's say I have this vector x, I write x equals to sum over of Vi, Vi, then the question asks us, which of these are true? If I take x dot product with x, that is less than or equal to n, or that is greater than or equal to n. Can you answer this question? How would you approach this question?
It's no idea now, sir.
Okay, so the way you would have to answer this question is using the probabilistic method. So the probabilistic method is that, okay, I do not know. So the question is, can I find a B for which either this is true or this is true, right? And right, and now this is not easy to answer otherwise. Like, it is a problem in geometry, but it's not so simple to answer this question otherwise. So so let's see how we can answer this. So let's take a random variable. So instead of considering this binary vector B, think of it as a random vector. Okay. So the random vector is, so let's write it this way. Think of B as a random vector. So B is this collection where each of these coordinates are independently chosen. So each of these Bi's is the uniform distribution on -1, 1, and they are IID. Okay. Right. Now consider this random variable. Now consider this random variable S, where S is equal to, where S is basically equal to the square of this norm. So that is S is equal to sum over of bi vi sum over of bi vi unit product. So it's basically the square of this, right? Now if we expand this, this is equal to sum over of bi bj bi bj. Okay. Now let me take expectation of s. So expectation of s is equal to sum over of expectation of bi bj, and this is a constant because these are fixed vectors, so they just remain. So this is by the linearity of expectation. Just give me a second. Yeah, okay. So this is the expectation of bi bj vi bj. What we saw from the last exercise, that expectation of bi bj is equal to this delta ij. So this is equal to sum over of delta ij vi vj. Now this is 0 if I is not equal to j. So this is equal to sum over of vi comma vi. Now these are unit vectors, so this is equal to 1, and you have taken it over i's, so the sum is equal to n. Okay. So the expectation of this random variable is equal to n. Now, if the expectation is equal to n, then that means that there must exist some, there must exist a value that this random vector takes, for which this quantity s is bigger than n, and something for which this quantity is smaller than n. So in fact, both these options are correct, and this is the right answer. Okay. So this is an example of the probabilistic method with which you can say a lot of these things.
How come it will be less than or equal to root 10? Similarly, it is greater than or equal to also root 10.
Yeah, and
That
both of them are true because so the expectation is equal to n. Okay, so that means so that means that if we take, so s, you understand, is the square of this norm, right? So if you take expectation of root s, expectation of root s, that is equal to root 10 basically.
Yeah.
Okay. Now the question is, why does it mean that that this is either bigger than this or either smaller than this? Right. So
yes, sir, yes, that's my question.
Right. Okay. So think about so forget about s. Just think of some random variable x. Okay. Assume that x is some random variable which takes only positive values, and so its mean is always going to be positive. So uh, if the mean, whatever that mean is, so let's say mu is the mean of that random variable, then there must exist some values that that random variable takes, which is smaller than the mean, and some values which that random variable takes, which is greater than the mean. Because if all the values were smaller than the mean, then the mean would also always be less than that. So for instance, let's say 5 is my mean, and my random variable takes all values which are smaller than 5. That's not possible, right? Because otherwise, if the mean would then be smaller than 5. Similarly, if 5 is my mean, and if my random variable takes all values greater than 5, that again is not possible. So the mean is somewhere in between the possible range of values which my random variable takes. So just let me just write it over here. This is the code. If x,
It's
sorry,
clear now, sir. It's clear now. Thank you.
clear now, right? Yeah.
Yeah.
So the mean is somewhere between the range. Yeah, it's never an extreme of the range of values at the time. That is the whole idea. Okay. This is an easy problem, but it's a nice problem. Now let's look at some of them.
No need to solve the third one, sir.
Okay.
Third one I got it.
Okay.
Especially the fifth one and the fourth one.
Okay. Okay.
Fourth one is also clear, sir. Fifth one only.
Okay. Let's look at the fifth.
Can we do the third and fourth one at the last, sir?
We can. Let's do the fourth one first. Then let's go to the fifth.
Sure.
Okay. So consider a stream of m distinct elements. So each of these AIs take values from 1 to n. Now let H be randomly chosen from a family of pairwise independent hash functions. Okay. Okay. Um, Okay. So notice that each of these random variables XRs, they are actually independent of each other. Okay. Do you get this fact? Do you see why this is true?
First one is actually true, sir.
Huh?
First one is
Sorry?
true.
Yeah, first one is true. No, but why is first one true?
It's actually defined as XR is same as sigma y. It's no, wait 1 second. XR is same as sigma y of r comma
Why
I.
RI? Yeah,
Yeah.
correct. But why is this true then?
Variance of XR is same as Y of R comma I, sir. So
Yeah, but
variance
why
of
does
XR
the
is same as
variance?
this one.
But
Yeah.
why does the variance distribute? I know, but when you apply the variance, why does the variance distribute? Is the question. Let me write it down.
See, actually, these are independent
Why
random
does the
variables.
variance distribute?
Actually, these are independent random variables.
Correct.
So there is
Yes.
no covariance exists, sir.
Yes. That's the point. They are independent random variables.
They are independent, yes.
Why RIs are independent? So okay, so why RIs are independent random variables? Are they also identically distributed? Is my question. Are they also identically distributed?
Yes, sir.
Is it? Yes or no?
Yes, I think.
Yes, they're also identically distributed. Because
Yeah.
H is randomly chosen. So
Yeah, randomly, okay.
assume that it's uniformly chosen from the set of all possible hash functions. So yeah, so it's also independent. And it's identically distributed. Yeah, so the first one is correct. Now the second one, why is the second one correct? Well, notice that each of these are indicator random variables. If you have an indicator random variable, then the indicator random variable has only two values in it. It's either 1 or 0. So expectation of y square, expectation of y will always be equal to probability that this thing is equal to 0. So expectation of y squared is equal to expectation is equal to probability. Yes, the second one is obviously true. And finally, it says variance of XR uh, is less than equal to expectation of XR. This you can verify. This is also true. Yeah, I hope this third option is clear, right? You just need to uh, solve this. I mean, what is variance of XR? So this probability is uniform for each R comma I. Basically, for each R comma I, this is uniform. So you can call it P because these RIs are independent and identically distributed. So your expectation of XR is equal to sum over of expectation of this thing there are m such ones, and so yeah, so there are m such ones, and so the expectation of XR is equal to m times p. Okay. Uh, Now, what is variance of XR? Variance of XR is equal to summation of variance of YR I. Now, variance of each of these YR I's is equal to expectation of YR I squared minus expectation of YR I. So, expectation of YR squared is equal to P, and expectation of YR Y whole squared is equal to P squared. So this is equal to P times 1 minus P, and obviously this is less than or equal. So summation of variance of yi is less than or equal to 10 times P. Third option is also okay. I hope it's clear.
Yes, sir. It's clear.
Let's look at the fifth problem now.
See, actually, options are all the three options or all of the above, sir.
Yeah, all of the above. Yes.
These answers we are confusing ourselves.
Okay, you want
All
me
of
to
the
take all
above.
of the above?
All of the above or all the three, sir? It's all of the above only.
Yeah.
Yes, sir. Okay, thank you.
Okay. So the fifth problem is consider the following stream of 50 elements. Yeah, I mean, some of these problems are kind of a repetition of the first, but let's still see. Uh, okay, okay. So I hope the question is clear, right? Oh, I just recalled I didn't start the recording. Okay. So as usual, let's y is equal to z squared is equal to summation of I comma j h k I minus h. let's write it as in this way: summation of I comma j, where j does not belong to I or I plus 1, phi aj plus sum over of I equals to 1 to 25, ai plus sum over of ai ai. So the reason why I wrote it in this way is because the stream it repeats elements. Um, so if I and j, so essentially by saying that j is not equal to I or I plus 1, it means that we're looking at two different numbers. So essentially it means that uh, ai is not equal to aj. So this is the first case. Okay. So if ai is not equal to aj, then what is the expectation of this? So yeah, I mean it's similar to the last problem, right? Or the first problem that we dealt. So aj, yeah. So this is delta ij, similar to what we discussed. So yeah, so you have 25 terms for which this is 1, and again 25 terms for which this is 1. So yeah, so you get 50 is the correct. Oh, yeah. Is it? 1 second. Hmm. Oh, okay. It's just a counting error. Yeah. Okay. Yeah. So it's actually 2 times this thing. Right, you can see why it's 2 times this thing, right? Because when you are taking the sum over of this, uh, each of these numbers from 1 to 25 appear twice in this because the stream is repeated. And similarly, also, so here you have ai plus 1, and you would also have ai plus 1 ai. So it's twice of that. So yeah, 100 is the right answer. It's not 50. Is it clear?
Yes, sir.
Okay. Okay. Then shall we move on to some different kind of problems? Do you have any particular problems?
Sure, sir. Sure, sir.
Okay.
Can we also do the third one and finish it and then we go to the other problems?
Okay. So, right. Okay. So let we have a class of 30 boys and girls, and we want to arrange them so that the girls stand before the boys in the line. Right. So the idea is that from all possible uh, selections, uh,
Sir, actually, we are arranging 50 students.
yeah,
So, probability of exhaustive number of cases is 50 factorial. Is it
yeah,
right, sir? Denominator occupies 50 factorial. But
yeah, but
girl,
it's not, but yeah, it is 50 factorial,
but girls
but
has to
some of these
occupy
arrangements
the
are identified, right? So, for instance, yeah, so the yeah, I mean the number of arrangements is 50 factorial only, but let's say
I
you
apply
have
simple
this arrangement
probability.
where you have girl one, girl two, and then boys, and this arrangement girl two, girl one, then boys. These two are identified with each other.
That is the sample space, sir. That is, I'm telling 50 factorial.
Okay.
Totally, you have 30 boys and 20 girls. Permutation only, sir.
Uh-huh.
So 50 factorial. So, but girls has to occupy the front portion, but girls has to stand together. Okay,
Yeah.
so you consider girls as a single unit. So you can arrange them in 20 factorial into 30 factorial ways. So it is, I got the correct answer, but I applied some other technique there. That's all.
Okay.
Its money answer is 20 factorial into 30 factorial divided by 50 factorial.
Yeah. Yeah. So that is basically like 1 by 50 C20, right?
Yeah.
Yeah. Yeah. That's right.
I applied simple permutation concept.
Okay. Yeah. Yeah, that's fine.
Oh, got it, sir. Thank you.
Okay. Okay. Fine.
Is my argument is correct only, sir?
Yeah.
Yeah. Okay. Thank you. I have taken in that sense. I got the answer also.
Yeah. Sure. Okay. Um,